All right, I am back. Despite the last stream where I got sort of in a broken state, I have fixed a couple things, and our project is about in the state that I left you on the last VOD that you'll be able to find. So that looks like this. So I'll just run it. We did get graphics in. Let me turn this music down for myself a little bit. Um, which this is obviously broken in a couple ways. First of all, it's supposed to say tic-tac-toe, which it does not. It's also not supposed to scroll. It's supposed to be stable. So we have a couple of issues, and they're going to be pretty hard to debug without being able to sort of step through our program. Um, so I've gotten a little bit, so I'll show you what the debug output looks like. We've seen this before. So here, kind of move that around. You can see sort of all the flags and stuff going through here, and you can see it start to draw. Um, I'm suspicious of how fast it draws those first couple lines, and then it goes through this. I feel like every line should take about the same amount of time, although the debug does mess with some of that. So we'll see how that looks. But you can see we have kind of every, well, we will pretty soon. We'll have every instruction that's being executed and show what happens on the screen at the same time. So let me give you a quick tour of what I've done in the meantime. Look at the log. Um, so I added STL2 and basic graphics. I've updated all that a little bit, but I refactored instructions. So let me take a look at the main.rs. I've also moved a lot of other stuff out of here, but here's the main loop. Instead of doing a big match statement on instructions, I've set it up so that I can grab an instruction by a byte, and I'll show you how that works, and then just execute it. And then basically I'm having all these other things like the debugger. If it's active, it can exit the loop, and the renderer, if it, which is always active, can exit the loop too. I'll come back to that in a little bit. Um, okay, so what did I want to? Yeah, I want to take a look at instructions, and so I've taken away that like instruction trait with the code and stuff like that, and I've basically just made a bunch of sort of functions that do the right thing on the system. These are pure These pure functions, I guess they mutate the system, so not really, but they operate on just the one input. And then they output the number of instructions that they, or the number of clocks that they take, which is sort of a runtime attribute of the instructions in the 2507. And so then I have this big match here. Let's see. It's very long, so I have all the instruction names. So for each instruction, these are all the possible instruction names. For each instruction names, there's one or more address modes that it can be run in. And so the instruction value here takes a name, an address mode, and then execute function, or an execute function. So that's one of those functions defined above. Here we see try from. Our error is just a string, which is fine. And it basically just does a match on whatever that instruction is. Returns if it can, and then sort of towards the bottom here, there's it'll return error if there's an unknown instruction. Since this doesn't cover the entire 256 possible values, there's not an instruction for everyone. So then I define this execute, so every instruction now that is possible will be mapped instead of exiting early. So you can actually pull in the whole program and basically make like make a debugger so we can step through the code. So we'll like disassemble them and try and print them out well. That's what we'll be doing this stream. And then basically, if I can't execute an instruction, then I'm erroring out so that we can just go ahead and implement sort of everything here that has a none. That may be a project for me on a weekend sometime when not on stream, because a lot of these are going to be kind of boring. Add it works the same way no matter where you are. Um, so cool. So the goal here today is to update this debugger to allow you to trying to think what you might need here. We can get there when we go along, but basically what I want to see is information about the um, information about like where we're drawing and what instruction of ours is being run. So I think the place to start with that would be to continue the disassembly of that code. So where we have this program here, nobody really wants a disassembly except for the debugger. So I feel like that should be a debugger setup. So currently we're just passing whether it's in debug mode or not to the debugger, but let's go to the debugger. Might change the name of this. Actually, let's go ahead and do that. Let's call this setup because it's going to do more than just what it did. Oh, I see. Hmm. So what I'm trying to think here is like, what do I do? Because I don't think I want to disassemble in every situation. Do I stick an optional on this debugger, or do I make I think I pull out a trait and the with some default implementations for when it's off. So then I don't need this is debug mode. I just need to decide which one. Hmm. Yeah, let's see what that would look like. Let's do that. So that would be like, so we need a public trait debugger. So what we know we need here and then debug loop. I'm just looking at see what it depends on. And tear down. Don't worry about setup. That returns a we'll just use result so we don't have to keep writing that over and over again. Result. We know this. Oh. Result. Just needs to return a unit. All of this is just basically whether it worked or not. We can have it. So this will be the default one. So we'll call this like active debugger. So it's, yeah. And actually, we don't need the is debug because we know that it is active. This is all going to be. Okay. Need. And then I'll take a system. Gonna be the same thing here. Actually, I can probably just make my life easier and pull down. I think the only thing I need other than that is tear down. So I'll grab tear down. And so by default, all this stuff is going to. So it says I don't need pub, I think. Because the whole thing's pub, so we're going to implement debugger for active debugger. And it's like, yeah, it's saying mode. What is it saying about mode? That's weird. Oh, yeah, we don't need this. We're gonna get rid of our pubs here. That should be all we need, and then we can do pub struct null debugger. So this won't do anything, and I think all we have to do is just impl debugger for null debugger. And it wants this, and it probably doesn't want a semicolon. And that should just work there. So then we'll just have a function that returns us a instance of the debugger trait. I think there's a problem here, though, right? Because we'll need the disassembled code at some point. Let's see where this takes us before we decide that we're going the wrong way. Then we'll do a do it right here. We'll call it like get debugger with the mode. Debug. It's going to be a boolean. It'll return anything that impls debugger. Probably doing something wrong here. Hopefully the borrow checker will help me. Trait bound. That's fine. So we'll say if is debug, return active debugger, else null debugger. So incompatible type. So let me see what, let's see what this. Gonna have a, yeah, so it's gonna say that. Okay, so it's saying that both branches need to be the same thing. So I think we are gonna do that. So to be a box trade. What does that say? So it says return a box. That's fine. We're only really gonna have one of them. And then we'll need box new. I think that fixes us here, and then we have some errors over here in main. Add the diag keyword before this. So that's actually not what we want. So we want from debugger, we want yeah, debugger debug here. Does that just work? So if we run it without it, it should just be normal. That's normal. I mean, it's not normal, but you know, it's normal for us. And then this appears to be working just fine. So what I was thinking is that the actual like display here, that's in the debugger module. So I think it makes sense for the debugger to hang on to the disassembled code because I'd really hate for that to be somewhere else. I think that can work. And so what I was thinking of is in debugger. So it's right here. It's like printing out all the pieces. So we could definitely do like remember disassemble program. Let's figure that out. Okay. So we are going to have the trade impl, but it's dynamic. May have to do some funky Rust stuff here, which is always fun. Yeah, let's clean up this warning. So what if our setup program took the program? Let's see if that makes sense. So we're getting the debugger up here. We could get it after we pull in our program and just pass it to the get debugger there, but we're also doing a setup state. So we'll still have to move something around. I like having the setup separate, but why don't we have the setup take the We've got like timing stuff is here, total time system.new. Render is being set up here. That's being initialized and set up in the same function. It's because I had to hold on to some stuff there, so. Yeah, actually, why don't we, since we're pulling the file in here, setting up system, total time, timing stuff, why don't we put that there and have the debugger take the program, which is a byte deck. Might have some problems with how long that lives. That's fine. I'm actually going to be making something new out of it. Let's see, what does our system take? Takes a slice. Doesn't do anything with it. We could do the same thing for now. Should be pretty straightforward. Right, so it's saying like didn't have the right argument, so we'll just do program. Yeah, they're just taking a slice of it. It's no problem there. So I think so if I do active debugger and I do I don't know what to make this yet, but for now we'll just make it a U8 4096. And we'll make it an optional. This. Say that we can make this. We'll derive default here, so we can initialize that with a none. Okay. Remove that semicolon because we don't need it anymore. Field is never read. That's fine. Program is good. All right. So as well as doing that, it's gonna call. Now here's the question: if I have a function here, impl active debugger, foo. For now, it's going to not return anything, and it's going to do this, and it's going to take a self. I think this won't work, right? Like if I do self. That does work. I guess it knows enough to know. Okay. So we'll want a mutable self here, and we'll call this something like disassemble. And that'll actually take this program, which I'm writing over and over again. Let's do it for now. Yeah, I don't want to get hung up on that. That's definitely refactoring, though. Six. So here we're going to, I think even before we do any of this, we're going to do self. This might need to be mutable self. Yeah, this is going to need to be mutable self. And that is fine. I don't think anything can go wrong with that. So this should be fine. What is it saying here? I spelled it wrong. Disassemble. Fingers don't like to type disassemble, apparently. Okay. All right. So basically what we have is we're going to have a mirror of what we're doing before, but we're going to go through the whole program instruction by instruction. And we know a little bit about, let me pull up the instructions. We know a little bit about them. And we're going to have to keep track of a byte that we're at. It's going to be interesting. I think eventually, like the assembler here puts out a symbol file that we'll need to pull into eventually. But let's get this first part working. Disassemble. Let's see. Instructions. We have this instruction value, which has the name, mode, execution. So we need that. I think we're probably going to have this be responsible for outputting code. This will be interesting. Okay. So, but then the address mode is going to determine how wide this is. And so I think, let's think. So we'll take the instruction value. So I think we're just going to keep this in a, oh yeah, I think I thought about this. Okay, so I think we're going to keep this in a B tree map, with the keys being the bytes because the instructions are different widths. We can't really do that on the fly, and we'll need to know where the program counter is lying. And then the B tree map allows us to get a range. Let's take a look at. I know I'm jumping around here a lot, but let's take a look at that in the Rust docs. So B tree. And so we'll insert rows, give with the byte address, and then the so I need to keep the arguments around. So we could like have this function turn it into a string and just keep an array of strings around, or a vec of strings around, or a map of strings, which will act sort of like a vec. Okay. All right. I think that's what we're going to try first, and we'll see if that works for us in the long term, because I think it's the easiest thing to do here. So instead of this, we need disassembly to be what is that? Standard collections B tree. Standard B tree map. It's gonna have a 16-bit integer as the key, which we'll figure out at some point, and then then we'll have a string value. Yeah, it's saying it can't do default for that, so that's fine. We can actually just oh, do we want to do an yeah, we want to have an option, so it can do default for that. Type annotations needed cannot satisfy. I think I'm good here. I think I'm just getting some junk. So I need collections B tree map. Does that all work? Okay, yeah, right. So we're not. So when we disassemble, we're going to construct a new one. So reusing words a lot here, but it doesn't know what to do. But I think if we set self dot equals sum, I actually think we can do like a replace there. Let's take a look at our options for option. That way it'll panic if for some reason somebody tries to set it up twice. So we want replace, I think. Yeah, I think replace is what we want. So, I thought there was a way to do that. Yeah, so I don't think that fails. I think it's fine. Yeah, it's saying it doesn't need to be mute, but that's fine. We're going to mutate it. So let's start inserting values. So we're going to loop over our program and then construct the strings from there. So we're doing that in a particular way already in the mod. Doing like next byte. That's not exactly what we want to do, or because it's doing memory access. So we want to make this into an iter and like get. So we'll do like a while. I think what I want to do is like kind of ugly to just set a value, but like I can't pull them out. I have to deal with the iterator directly, right? Like so I can't like do for in because I need to like be able to get the next values sort of mutably, right? And in fact we'll need that's fine here, I think. So while not done, we're gonna do something done equals. It's probably a better way to do this. Maybe there's like an is not. Actually, iterator. We've got next. I could. So I want to like see if the next one is some without taking it. Is there like a peak or something? I don't think there is. Let's see. Peakable creates an iterator which can use. Okay, so I actually want that to look at the next element iterator without consuming it. See the documentation for more information. Um, so peakable. Okay. So let's go ahead and let me program iter. It probably needs to be an iter mute and peakable. I don't need to mutate anything. Okay. So then if while program iter.peak. As long as there is something here. I don't need this to be mutable. I do need it to be mutable. I thought it was telling me not. What isn't it like about this? Okay, I'm not sure what's happening here. Oh, it's saying it's an unknown word. So I'll add that to my dictionary. People's a legit word. So we don't need done. We've got our disassembly. So we're going to say let instruction equal get program dot next. So this is, we've already checked, so I'm fine unwrapping it. Program. And then we're going to do try into unwrap that too. And we're going to turn that into one of our instructions for the, so we'll need, we're going to do use, actually we can do it from here. Instruction value. Not found instructions. You're wrong. Why didn't it let, did I spell it wrong? Yeah, I spelled it wrong. I'm wrong. It's always how it goes. Okay, so then I'll just make this an instruction value. I need to use parentheses on that unwrap. What is it saying? From so I need the owned value. So we'll just go instruction first. So basically it's because it's the iter, it's borrowing the value and I need to actually get at it. It should be copy, so it should be good to do this. And then let instruction value equal dereference that. Try. Alternately could implement from borrowed U8. That might be a nicer thing to do, but let's see if we can do this. Oh, it doesn't know what value that is. Cool. So that's an instruction value. Maybe it doesn't know what to do with this. Doesn't like that. Why is it not? Why is it having such trouble here? So this is going to be like, this is going to say, so if I dereference this, it should work. I'm wondering why not. Oh. Okay, so that did work. I just needed to add some parentheses, which is always fun. All right, so once we have the instruction value, we're gonna print it. I think I'm gonna implement all that on the instruction value itself, including the printing of arguments. The only thing that's going to get interesting is when we have a symbol map, we're going to have to figure that out, but that should be... Let's cross that bridge when we get to it. So we're going to say disassembly insert. The key is index. So we're going to need, actually, I think we need an iterator like with index or something. I think it's enumerate in this case. Yeah. And this is all wrong. Because I need the... So I actually need to dereference instruction.1. Okay. So for our key, or let's do that key. We're going to take r dot 0, and then we're going to add a magical value here because we just happen to know where this stuff is aligned. This is definitely for yeah, it's aligned at, actually, do I happen to know where it's aligned? Let's look at the... I didn't. That's where it's orged. I'll do key, and then for now, I'm going to make sure that it's all compiling just fine. Okay. So it's saying found use size. So I need to do this. Key as U16. Okay, that's our same old error. And now we've got to format this stuff. So we're going to let values. So we're going to do a format. This will be, so we'll want to show our address. So this will be our key. And then we'll do for our instruction, and then our arguments. This will be just a value, and we'll then we'll have to figure out the rest of it. So let's see if we can get this far. And then maybe we'll figure out how to start printing this out in our debug. Information doesn't implement display. So yeah, we'll need to do that. I think I have display implemented in display. We'll just copy it. That's not an easy one to copy. We'll do this one. We're actually doing that for the... I won't know how to do the argument. Start it this way. I think we may need to standard T. We don't need all this stuff. We actually don't need much here. So for now, what we need is and name. And then that doesn't implement display, so we need to do that for name. Then we're going to this is going to be kind of silly, but I think it's good for now. So we'll make ourselves a little macro. Let's try that again. So QW, we'll yank in this current word, and we'll go to, we'll insert our little arrow, yank surrounding word. Whoop. going to be pretty complicated. And then we need to find this and 2 and then we'll go to the next line and see if we didn't mess something up. Oh, we did mess something up, so that's good. I think it's that yanks around inward. I think we can't macro that. So we'll need to do this inward. So we'll do end our hash bracket thingy. Much better. So we'll need to... I'm going to do something not great for capitalizing all that. How many more are there? There's like 20. There's more than that. Okie doke. And we'll just highlight all of this all the way up and make it capital. What doesn't it like about this? It's saying like, oh, I'm getting doesn't recognize this. So I may have to do something similar. That value is a string already, so we'll just pass it in here. And that should give us what we want. Let's make sure we don't have any more errors. So it's saying that it can't, for setup, it can't borrow this variable. So let's go to main. Okay. So then let's actually output some of that. So I don't think we want to do the whole thing. I think that'll be insane, right? That'll be the entire program printing out every time. So when we're in the debugger, and then we're printing some stuff out. So at the end, let's queue another. And instead of that, we're going to do self. We're just going to index that by our system.pc. Chat.pc. And we're just going to do it because we happen to know that that's, yeah, it wants me to borrow. Consider borrowing. Oh, what is that? Let's see what that error is. Move occurs because, okay, it's not implement the copy trait. So we want to do as ref, which is fine. Okay, and so then we should, let's actually make a little header, and then print out the string. Everything is caps in most of this program. And then we're not running it in debug. That's fine, but it compiles, so debug works better out here. Unknown instruction FB, right? Okay, because we're not pulling the rest based on what we need to do. So I can't actually look at this. Okay. So here, based on the I think we need like a yeah, okay. I think we can do this in a pretty cool way. So basically I'm going to pass the iterator, I think, into a function on address mode. I'm gonna call it like a function like format arguments. That'll return us. That'll take a. So we'll say that it's anything that impulse iterator. For U8. And then it returns just a string. Move generics. So yeah, so it's an associated type. Which I think I need sort of generic argument for T. I don't think I can do it this way. T, let's see what it says about this. So I want like where T is iterator, T item is U8. nope, not U9, U8, and then stick it. Let's do. Get to compile. It doesn't like how I did where. Does that come after the? It's been a while since I've done this. Does it come after the? Where? T. U8. Where key item. Let's see. This might mean some brute force Googling. Of type. It's not what I wanted. Did I say type? Oh, I can just do that. No. What's it saying? I is iterator with an item. Oh, it's going to need to be lifetimed. I think that's fine. Equals U8. I think it's going to be borrowed, so I think we'll have to mess with that a little bit. But what I should be able to do is say I've got an instruction. And then I should be able to do format arguments here with, I think I have an inst value, address mode, format arguments. And we'll pass our program iter. Oh, I need to take self. And that's private, so we can actually probably pull this out to pull this out to the instruction itself. Right, not into display, but into its own. See what it doesn't like. Expected U8 found tuple. Right, because we have the address on it too, and we don't really care about that, but we do need to take it. So it's item. It's a tuple of and a borrowed U8. Need a lifetime argument, so I think that was shown here. We can do this impl version, so maybe we'll just do that. We'll just leave it like this. So .a plus this generic argument. See if somebody's done that properly somewhere. That's a comma. Values move there. But I'm giving it back. Take a reference to that iterator. Okay. I might need it to be a... Might need it to be mutable. Okay, so I think that works, right? So I'm passing in the reference to that iterator, and then I can, based on my type of argument, I can, so if I do self dot address mode, match it, yeah, so there's a bunch of stuff I need to do here, so. A bunch of them are going to be the same, so I can probably make this. I think the most we have is 2 wide or 3 wide. So I think our absolute. Oh, but they might be formatted differently. Yeah, they're definitely going to be formatted differently. So that's fine. So what does this look like? For our absolute addressing mode, we're going to do this. Go low. Iter.next as U16. We've done this a bunch of times. I oh man, right, we need one. That's fine. So we're going to do the same thing here. One. And then we're going to format. take high, move it, shift it over by 8, and then add low. And then I need to make sure that I have the precedence correct here, which is 1 second. Let me make sure that I'm not missing anything important. All right. The absolute address is going to look like this. It's going to look like this standard stuff, and then it's going to be it's going to be the hex address, but without the hex stuff. Let me see something. I think I can just do 0.4, and then add 0.4x. Getting used to this new. That should return me a. So that seems about right. So, and then a lot of these are going to look very similar. I could be smart about it, but I think it's fine to just kind of repeat this over and over again. So I'm going to repeat this whole block for absolute x, and absolute y is going to look almost exactly the same. Clean it up later. And so it's going to be similar, but instead we're going to do comment and an x. Then we'll do the same thing for absolute y. Just do this part. Sorry, just making sure nobody needs me while I think about it. And then absolute indirect, which is going to look even different, but be very similar. So and so then instead of all this, this looks like that. And then accumulator is easy, so we'll just do that. And actually, accumulator, immediate, and implied are going to be all the same. I'll have to look at relative. I don't remember what relative is. Oh, okay, yeah, no, that's going to be different. It's going to be the same as. Is this right? Hold on. No, immediate's different. So. I think I'm gonna have to put the name of the struct in front of all this stuff. So I'll do that in a minute. So this is gonna be a format. It's gonna, hold on. To owned. There's no arguments to these. So this needs to be. So let me go ahead and do that now since it's going to complain about it. Some of this stuff I'm gonna have to look up. So immediate mode. Unfortunately, that could be anything. I think we want the hex value. But take a look at something real quick. Oh, it has the hash on the front. Okay. So then the indirects have. Okay. Good. Easy. Immediate mode. So we only have the one value. We don't have these. Don't have these. We have a value, and it's going to be 2x, and it's going to have a hash sign up front. And that's how we show immediate mode. And then relative is going to be, let's see, mode. Yeah. Two, just gonna have that. Okay. I'm trying to think if any of these are gonna have the same syntax. They're not. They're all just gonna be a little bit different. So um, this is gonna have in a value. This is a what's that? We can call it a value. And then the 0 page and relative are going to be the same. Page. So relative x is like this. Right? The x is inside, and relative y is the y is outside. And then y is going to be much the same. This is not in parentheses. The indirect with y, that's the y outside of parentheses. It's because they work slightly different. And then I did not see absolute indirects with no. Okay, I had absolute with y outside. Okay, absolute indirect with X and Y offset are not available on this chip. So let's see if I have any issues. No diagnostics. So let's see what our debug output looks like now. Hmm. So I probably got widths wrong somewhere. We'll see what the instructions look like, and then why don't we do the instruction and the instruction value. Let's do the whole instruction value. Doesn't implement debug. So instruction. Should be able to. I don't think it's gonna like that. See what happens. Yeah, it doesn't like that function. So why don't we make address mode public for a second while we debug this? Woo. And name. Wonder if I have some reserved bytes sitting around. I probably do. That's probably what's going on. I'll have to figure out what to do. So if I don't have the instruction, I'm not actually going to blow up. I'm going to do something different in this case. Okay, we'll see. We'll see. Because at the end of the assembly program, there's just a bunch of data that's just sitting in bytes. There shouldn't be any instructions after that stuff, but I feel like there could be. So we may have to just keep outputting bytes until we get to. That'll be interesting. Okay, let's do a value bar, partially moved value. Okay, so I'll just take a bar. Can't leak private. Man. Name. Address. So yeah, I'm guessing that's coming right when I have some data in there, because we're loading X media. It's the first thing we're doing, and then that should have it. So that jumps it by 2. So we're getting this far. So let me see if I can. I'm like torn between having something wrong here, or being into some data. I think I'm gonna be into some data, but I may have like implemented one of these wrongs. Address mode relative. Did I not pull off? No, I have other ones that are relative and they didn't break. So let's see. If I look at my source, so I'm thinking I got into all these bytes, right? So we can verify that. Thing is, I think I could potentially, let's see, data tables aligned to 256. It just aligns it to a. Okay, so I have. So I'm betting I get into like these bitmaps and stuff. So let's see what's at the end of player loses. Return subroutine. uh Fun. Okay. I think I have something else I can debug that'll give me a little better idea of where in the program this is. So I want to debug this key too. Um, so our key. Oh, might actually want to. I want to print it out so I can format it in hex. It should be 16 bits. Key. F2A3. F2A1. It's hard to tell where this would be. So instead of just failing, I think we just like maybe hard to get a disassembly without just a bunch of random bytes, but we can get a bunch of sort of garbage values in here, and I think we'll be fine for now. I'm trying to decide whether we're going to format them or. So it's where we're unwrapping here. So we're going to say, instead of unwrapping, I'm going to do like an if let if this is a sum, no, if this isn't okay, value. Then we're going to do this. See if it's giving us any help. Doesn't know what it is, so how do you do it? No. Is this how you do it? No. Okay. That'll be a quick look up. Okay, so I want the results first. Okay. That's fine. That's fine. So it's saying do this on a different line, which is cool. So then I say value. Something doesn't like something here. This is not right. And I'll need to call this a result instruction value. And I don't care about whatever else is here. It's going to be a super result. So I think one generic argument. Right. Not found in this scope. Okay. Doesn't it like here? Found struct box expected string. So it doesn't need to be a super result. It can be this. Doesn't it like? I'm not specifying the string, right? It's saying like Found struct box dynamic error, but I am turning a string out of that, but I don't care. Will that work for you? Okay, so we're using a crate result, but that method turns the wrong kind of result. I don't care what the error is. Oh, I see. I'm specifying the error. Okay, okay. So I just need to grab the standard for this situation. Gotta love Rust. Just makes it easier. It'll be very right when I'm done with it, though. Standard. Result. So it's result. Okay. So then, if I don't have that, I'm just going to... This is the same, so I can actually... Does that make sense? How would it be the... Yeah. So this can be out here. Key will always be the same for each loop, and then the value is going to be .1. So it's going to be the tuple to string. Okay. Called unwrap on a none value. Uh-oh. Instructions 1360. So at some point I got to there and I unwrapped it and it didn't like that. So maybe it's not safe to unwrap here. I might have something that looks like an instruction at the end, but it's not. Like in those last bytes. I feel like I want to say that once we can't find an instruction, the rest are bytes. And we'll just be putting out bytes. And if we jump to them, then we'll see that we have that wrong if we're like in the middle of bytes. So instead of like, so like at the top here, we want to like let me in data is false. It's a little hacky, but it's fine. And then as we go through, as long as there's a next one, as soon as we drop into here, we do in data equals true. And don't think we can do compound. But let's see, not. It's been a while, so maybe they've got that working. It's unstable. Okay. So we'll have to like So we'll just have to duplicate a little bit of the stuff here, but I think it's fine. So if in data, then we'll just do this part here, and then we'll break. We'll continue. One sec. Semicolon. No entry found for key. Okay, right. So eventually I got to a key where the program counter, we can see what the program counter was. It was 1,000. That was pretty early. Like nothing set. So I don't think it's safe to do. So we're just indexing into the disassembly. So I might have to do a little bit of wrangling these bits. So if our PC is at, let's just take a look at what our PC is. Oh, I can't do that in debug. We just saw it, so we know what it is. It's 1000. It's something like that. I think we're initializing our program counter there. So let's take a look at that. 6502. Let's see. Mod PC. I think that's what it's initialized to. The only thing that matters up there is that bottom byte. So I think it's fair to like change how we're indexing this thing here. And it with not bottom byte, sorry, bottom bit of that top bit. So that should work for everything. Oh yeah. Let's see. So let's look at our B tree map and we'll get something that'll give us a little more error. Get, which returns an option, which we can then unwrap with more. Maybe we can just put out that B tree map when we're done with it and see if it makes sense as a first step. B tree. and it'll take over the terminal. I think we'll be able to see it once it. Yeah, let's borrow that. Yeah, it took over the screen. I think everything I did was gone there, but let me make sure. Uh, yeah. So then just panic. For no reason, we'll panic. Okay, so yeah, it does look like there's just a bunch of bytes at the end there. Let's see if we scroll up. Control. Bunch of zeros and stuff. Oh, I think we need to chop off where we're actually putting them to. I think that's the problem. But yeah, this looks right? So we have a load XA 0. Doing that twice, that seems wrong. Oh yeah, no, that all looks right. So that's our program. Um, we'll probably want to change how this is output to hex. So that'll be 04x. But we're looking at the debug of the, yeah, that's fine. That's fine. What went wrong again? Second, let me check on everybody. Okay, cool. Right. So I think it's where we're inserting values. Hmm. It's not moved on from that. I think that's interesting. We need the rest of these. It's chopping off everything, but I just need to chop off everything above it. There we go. And now we can see it running through instructions, which is exactly what we want. And so what I'm going to do is, instead of doing that, I'm going to get a range of them. I'm going to highlight the current one using cross term. I may need to move other stuff around, but we'll do like 5. But you can see it's pretty much working, which is really cool. And the next thing to do will be to figure out how to get it to stop. So let me do this slicing business. So instead of this, we want like range. So do this. We don't need this stuff, but we are going to need to do this. Then we'll do for line in self.disassembly as ref. Just unwrap that. And we'll do range. And our keys are going to be our system.ship.pc. Let's pull this out. We're going to go current line equals. So we'll do current line saturating sub. So we'll make sure that we don't go below 0. Although we're doing that. Yeah, actually, let's do this. Yeah, because I can't get the range underneath that. I wanted to give some context before and after, but then I need to like. Okay, let's start with the chip PC, and I'll do. It's not current line. It's our PC, and we'll just say. That's not quite right. I think this will get us an out of range error if our PC is at 1,000. Okay, I think the first thing it'll do will be get everything, like 5 things after this. So we'll just do current line like that, and we'll just do current line and current. And maybe I just won't worry about it. Or I'll worry about it off screen. So we'll just do +5. Yeah, because I was going to get an index out of range error, maybe. Actually, you know what? Since it could be sparse, I think I'm probably fine. I think it'll just give me nothing for those, right? Let's see what... So I'll just do a... It'll just give me all the keys. And we'll do it more than 5 because these could be many long. So I'll do 10 and 10. Okay. What doesn't it like? Oh yeah, it wants more in the for loop. This gives us what? A key and a value. So this gives us a key and a line. And then inside there, it might be a little janky. We may have to do something special to like get the right number of values back, but it's saying range. This needs to be a tuple. Acquired by this found in B tree. It's not implemented for U16. U16. Can I do this as U size? Well, then it's not gonna like that. Maybe I need. Yeah, that's not right. Okay. What isn't it like in here? So what is it saying? Okay. Constructs double-ended iterator over a sub-range of elements in the map. It's the best way to use it. Range. Min-max. Bound T. So the example here says, oh, okay. So it wants a range. It doesn't. Got it. I was looking at that wrong. So it wants. Cannot because implement copy. So I don't want to. So then I'm going to print. I think line's already what I want. So I don't want this. I want line. Don't care about key. So that can be an underscore. I think that'll work. So I think it's going off the screen. I think that's what's going on there. Yeah. Let's get rid of printing RAM and see what it looks like. Right. It's just gonna get rid of printing the riot at all. It's kind of a bummer, but I'll have to figure out how to get all this stuff to fit on screen. That didn't work. Maybe I'm printing out the... It's cool. That's going super fast, but that's the idea. Let's see. It was doing something weird for a second there. Let's see if we can highlight the current line. I don't think it's the right. That's the problem. Where's the memory? I think it's coming from the system print. Mod. What is printing the... Yeah. I can just search the project for RAM. Okay. It's here. Where is this? It is in system. I just missed it before. So... Okay, so the flickering is happening, I believe, because... Yeah, because like it's a variable length because the instructions are different lengths. So I think we'll need to get a big range and then like cut it down um, to make it like make sure that it fits in there. But I think we're getting something good. Let's see if we can invert those colors real quick. Debugger. We're gonna do like if current line equals key. We're gonna whoop. See where we set up colors. Set foreground color white. So we'll just reverse this. We're going to queue up the same thing no matter what, but we'll set the foreground color to white. Out. Set foreground color white. Right. Dereferencing borrow. So actually I can just do this. Set for color white. Okay. And we'll set the background color. Color. We're already doing this. We need to go the other way. We'll need to. Then we're going to undo that after we print it. And that should give us highlighted current instruction. Yeah, that's awesome. You can see it sort of jumping through there. I may or may not make that look pretty at some point. But that is pretty cool. So that's it running through our disassembly. With an instruction there. Pretty freaking cool. Yeah. Let's we're about 2 hours and 15 minutes. I'm going to drink some water, take a quick break, check on some stuff, and then I'll be right back. All right, we're back. I think the last thing I'm going to try and do for today is allow you to pass in a breakpoint. It won't work how you might want because we don't have symbols yet. I think that'll be another sort of stream, and we'll do that. So I think what you're going to want are two things. You're going to want to be able to dump an disassembly, which I think should be pretty easy. In fact, I might just go ahead and do that. Look through that, and then add a breakpoint for the debugger. And we'll do one for right now. So the first thing to do will be to dump the disassembly. I think that's pretty easy to do. So we'll say back in our main, let me make sure everything is good. Where we have our one. So it won't even be what's this symbol, and that'll be a Boolean flag. And that'll just sort of like return if we do that. So we'll get the debugger set up. Let's see if I need anything else. I need to have the program, but I don't need kind of any of this stuff. So we can pull this after here. And then we'll say if disassemble, then we'll print the standard out. I'll just return out of that. So we don't have dump disassembly. Okay here, that's fine. So we'll do, this will only work if you have the one, but it's fine, it won't. I'm gonna be able to use this on both. This won't be failable, it'll just string. We'll need this for our real debugger. So if we pass in debug, let's see. So let's see, if we have this symbol, if debug, it's a little, it might be nice to get the good message instead of just printing out nothing. Else we will must be debug mode to print. This is sound assembly. There might be something with a clap where I could do that. But we'll do this for now. So that way, if I run with should give me some oh, I did something wrong. Just make that a long. Should get some usage. No, why not? Disassemble. Okay, so if I do just assemble GMB, okay, yeah, we got that. And then I can also be in debug mode. And then it prints nothing, which is fine. Oh right, it clears the screen first. I still think it should be fine, but let's see what happens when we so I want that in this. I think we're just gonna have to loop over the whole thing. So for B tree, like we don't really care about values. I think we might values. Value for line and self dot assembly dot values. and we will print. Oh, it returns it. I don't really actually care for it to return anything, so we can just have it print out just simply the standard error and just return it. Okay. Fine. All right, we have the trait. This is yeah, so. Right. As ref. Oh boy, broke something good. So, 3371999 and 68. I'll do it for this one too. Seven one nine nine 69. I think I have a problem because I have my terminal node all messed up. So I do think I need to figure out how. I think it's the setup that needs to happen. So we'll just do this a little differently. If it's I need to program. You know what we'll do? Easy. Make this take the program. We'll do. Let's call that method again. Don't think this needs to be mute. Don't think this needs to do return anything. So instead of doing this, we'll do, what is it? The symbol takes mute. I think that'll be fine. Little hacky, but I think it'll be okay. No diagnostic. So if I do that, that looks not quite right. I think I need to put out the program. Okay, that looks right up until you get to the bytes, which I should be doing those correctly. And I'm not, so that's my problem. I'm unsure if that's actually just a bunch of bytes. I may have to do something to figure that out, but I don't need to deal with it now. Okay. Some water. Now I see what's going on. Yeah. So I need something closer to this for both of these. So key. And that's not actually right because it's just going to be a byte. So actually just the okay, that looks a little better. So we'll commit those changes. Add flag to dump. This is simply. probably pull all of that into the debugger and have it handle it, but I think that's fine for now. I think the next thing to do is push that. Is give ourselves a breakpoint. And I think that's probably gonna be about all we'll do. We might need to do like next implement N and C in the thing. We're not gonna echo the input or anything at this point. We're just gonna make it functional and make it better later. So, um, so we'll do break. Need to be at U16. And then we'll pass that into the debugger setup. We'll ignore that flag unless it should be an optional. Trait requires 3 parameters. Okay. Let's see. Yank to there, and then so in that case we'll keep it, and in this case we will ignore it and set up. And so in that case, I think got a breakpoint option E16. So then basically in our debug loop, we're going to print stuff out. We're going to flush. And then instead of pull duration, we're going to pull. I wonder if there's a way to do. This is. I want to pull indefinitely, basically, until a key comes in, and then do something about it. So, let's turn on pull. Timeout duration checks if they have false, guarantees a call to read. Function block. Can I just do? Maybe it's a duration thing. Wonder if this is event. Wonder if there's like a different or blocks until an event is available. So we'll want to. So you want to read if we have a debug and we're in the. We'll just do this in like the if some point self dot breakpoint can I say breakpoint system chip PC unstable. Okay. I feel like Clippy will tell me something here if I do this. So we're going to do something like this. And then we're going to do read. So this will short circuit no matter what. So we'll do if breakpoint. System.chip.pc. Then we just do this whole thing. It's getting a little bit nested and crazy, but we'll see how it cleans up later. Okay. See what read returns. Returns result of that. Oh, I see. It's just the poll that's different, actually. The read is the same. Interesting. I still don't think I can do that, but we'll see. So that's what I expect. And then, right, so I can actually just do this. Then I'll probably need to match in here. And then this breakpoint is not going to be quite the same. So we need to do breakpoint. We'll just shadow it with breakpoint. So we're making sure it matches these bot 0x1. The same with the PC. system chip PC. Then if you escape or control C, it'll return an error and break you out. So this should actually stop us somewhere. We just need to find a breakpoint. So let's do cargo run disassemble D. We'll output that to, whoops. We'll do that again. We'll do that again, but output it to our program. Let's find a fun place to stop. Let's do just 1007. Oh, this will be interesting. I might need to figure out how to make clap take a hex value. Oh, let's not deal with that. Okay, so let's do decimal for now. It's not very nice, but I don't want to. I'll write that function eventually. Actually, let me make myself a to-do on the clap arguments. To take hex argument. Okay. Enter hex number 1000. We'll just do 7. Convert 4103. So I don't think that worked. Yeah, that did not work. Yeah, so I'm guessing that never is true. Why would that not be true? Yeah, and this is getting tough because I can't just straight up output it. I can queue up some stuff. I'll just put it at the bottom. I don't know that there's room. Let's make it -5. Shrink this a little bit. Move this after the flush. It's not ideal, but we can then do PC, and then breakpoint. We'll want to see both of those as hex. Not seeing those at all, am I? So it's not setting the breakpoint. Did I not update it? Setup. I'm not using it. That's why. Self dot breakpoint equals breakpoint. Awesome. So it broke because it didn't flush out where we're at, but it's here. And so if I hit escape, then it... Cool, cool. So that worked fine. We'll just need to move around all this stuff that I did for debugging, which is always fun. So I don't need this anymore. I want to put the flush before we deal with events. And then, of course, we need to... Stanley. Whoa. I think I can kill all of that. That all looks good. Yeah. Nothing's running. Okay. So that is Rust Analyzer or Clippy, like hanging on to a process, and then I'm just starting to run it too fast, so I just need to be a little more careful. Okay, so there we are. We're at where we said we wanted to be, which is 1007. Why don't we see what happens when we get out of that loop? 1009. So that'll be 5. Nope. So once it gets through the loop, it should break. Good stuff. And then when I'm here, I should be able to... But then I just need to handle some key events in this user canceled execution. So we're going to do match code to do these differently, won't we? Yeah, okay. So I was thinking I could combine those, but I need this like aware modifier, but I think I can just do... I can't fall through, but I can do like... I'll just... And I did not do my match, so that's why that's... So match... Code... So what is it complaining about here? So that's the right thing. That's the right thing. That's the wrong one. I guess not where, I guess it's if. There's a lot that aren't covered, so in any case it's not covered, we'll return this. going to return it. We could just return the value that comes back. No, because I might have to do other stuff. Actually, we can just do this and return. Okay. No matter what other key is pressed, we'll return okay. All right. So then we got if we got basically this, but without the modifiers. So delete 2. I got preempted for music again, which is fine. I'm not gonna worry too much about it since I will be almost done here. So we'll see if we can continue. So here we have, if we have a breakpoint and breakpoint equals PC, and we're gonna have another sort of and self dot in breakpoint, which doesn't exist yet. Let's stop on the next one. Yeah, so we'll go through the loop once, stop on the next one. I think that'll just work. I think I can just do that. C. No, we want, that'll be N. C will be something different. So C will set debugger to self dot in breakpoint equals false. All right, so then it'll continue on. So then we need struct active debugger in breakpoint. It's false by default. It's Boolean. And then it's going to complain about it somewhere. No, we're getting default, so that'll be fine because it'll be false by default. And then if we were here, behind, so it wants me to dereference self here. Nope, why does it? Let's see what we'll see what happens. If self.in breakpoint, and if we do next, then we're actually doing self point equals true. And what isn't it like about that? Self is behind an at reference. So the debug loop has to be immutable, which is fine. No diagnostics. So if that is working correctly, after it gets out of the loop, it should break. It did not. I think it's because and needs to be an or. I need to kill everything again. So once it makes it through that loop, I should be into a breakpoint, and then if I hit N, Does nothing, which is cool. I hit continue. It does nothing, which is cool. If I hit this, oh, I'm not. That's right. Okay, I'm not sure what happened there. So I need to be focused on the terminal here. So if I hit N, did that go to the next? Yes, that went to the next one. That went to the next one. That is going to the next one. So if I continue, it'll just keep going, which is pretty cool. So I think we have what we need for debugging this here. I would love to get symbol files in here. Although probably, I think we're done for the day. What time is that? 3 o'clock local time. I think I'm done for the day. But I should be able to like take a look at the state of everything as I draw, which is what I want. And I can set a breakpoint somewhere in the loop here. I'll have to find that. But it shouldn't be too bad. The symbol file has things orged at F000. It's interesting that the program counter starts where it does. I could just make... I think it's fine, though. I think I'll just do the math. Awesome. All right. Let's see. I think I like the size of that thing, or of this, but I do want to go 10, 10. And I want to get 3 of these. I want to kind of get the 3 before, and I want to get the 3 after. So if I have, I'm going to get keys. So if I take, see if I can take around the middle. So we want, let's look at take. This might be a little difficult. So I'm sitting here. I do take while. So take some number. I want to take 5, but I want to take them while I'm in the middle. So I like, let me think. If I have an iterator and it has some number of things and the thing I want is in the middle of it, I want 2 after and I want 2 before. So I can take while. Maybe I need like index of or something like that. And maybe I won't get stuck on this. Okay, sorry, I was fixing the music real quick. So maybe it's try find nightly. So I want to do instructions here in this range. And then I want to get the R position. So yeah, I want to get equals R position. We need a thing here. That'll be it. It's actually a key value. We don't care about the value. And we want key to equal current line. We should find this. It's an error if we don't. So we can't compare. So we want we're going to have a key line. Do we have that? Yeah. In -2 +2. I think that'll need to be an equals range. Need a slice, right? So okay, so we should it's getting a little hairy, but we should be able to say like let's see what we're getting here. Okay, so it can't work with the exact set as required by our position. Okay, so that won't actually work that way. So maybe this is not worth the time right now. I think I'm going to call this not worth the time right now. Let's deal with a little bit of messiness. And then, is there anything else I wanted to do before I go? After it's out of this. Yeah, so I think it's doing here is loading up play fields. Maybe. I think it's like waiting until it's. Yeah, there we go. There, it's definitely loading some play fields and storing them. Cool. So next time around, we will we'll actually start debugging that output. But I think we're in a good spot. Let's see what we have to commit. To remove program. Yeah. P. That all looks good. Step debugging. Go ahead and push that. And there's only a couple of us, but I will find a place for us to raid. All right, TJ, it is with all three people. I'll see you guys later.